Hi, I'm Vladyslava, and today I will be discussing the topic of extracellular matrix and its benefits in medicine. So what is extracellular matrix, or ECM? Within the body, extracellular matrix is a collection of strong fibers made of glycoproteins, such as collagen, proteoglycans, fibronectin, etc., and is located outside of cells. The function of extracellular matrix is to regulate the behavior of cells. So what use could we have for this in medicine? Well, say you have a laceration on the body, and instead of wanting it to scar over, which is the body's normal response in order to prevent infection, you want the tissue to completely regenerate. This phenomenon can now be accomplished. Thanks to extracellular matrix scaffolds, we can regenerate tissues in almost any wound and help the body heal itself. So what is a medical scaffold? A medical scaffold is a 3D structure that provides support for a wound and prevents further wearing and tearing. Well, what kinds of ECM scaffolds are there and how are they derived? There's a plethora of different kinds of ECM scaffolds that could be used on a wound. For example, a xenograft, which is materials from an animal, or allografts, which is materials from a human. However, the most effective form of ECM is made from a urinary bladder matrix, a UBM, and is derived from the bladder of a swine. Here is an image of a UBM scaffold. So what exactly is the ECM scaffold composed of? It is composed of 2 layers, an intact epithelial basement membrane and a lamina propria layer. Carbohydrates, collagens, and proteins are embedded within the layers. So why use a bladder matrix? The bladder is a very regenerative organ that is easy to process because of its conical shape. So how does the ECM work on a wound? Say you place a UBM scaffold on a wound. The body sends neutrophils and macrophages to enter the ECM, and when it sees that the foreign object is non-threatening, blood vessels begin to integrate the scaffold into the wound. The basement membrane degrades and releases cryptic peptides that stop the body from creating an M1 response, which is scarring, and instead facilitating an M2 response, which is regeneration. Polypleural cells, or stem cells, are differentiated by the peptides, and the specific cells move to the side of the wound to regenerate all the tissues and nerve structures. With this invention, we can help so many patients recover and regenerate tissues that formerly could not be healed properly. There is a myriad of different uses for the scaffold, including cosmetically, on war veterans, on burn patients, and the list goes on, which is why the ECM scaffold is one of the most innovative inventions in modern medicine. Thank you.